So the typical myths, and these were covered in the Telegraph article. So the first thing is it's a new technology, and I hear this quite a lot in the UK from lots of different customers, both as GSHPA and with my own business. So most of us hopefully on this call will know that this technology is not new. It's been around since the 1800s, late 1800s, and I think it was 1946 when the first heat pump as we know it now was introduced. So that's the first myth. It's new technology. We need to wait till it's ready to go. It's not really ready yet to be deployed in the UK. So yeah, we shouldn't do that. Another myth, you need a well insulated house. We hear this one all the time, and I'm sure everybody here will know that as well, that people say, well, you need to have you know, this much loft insulation, you need to put external wall insulation on, you need to double glaze your windows, and these are all the things you need to do, and if you don't, your heat pump will not work. It will not work, and you just might as well just not bother. Low flow temperatures won't heat a building. You know, we need 21 degrees in a house, but of course you need to burn gas to make 80 degrees seawater. Of course you need to do that, and if you don't do that, you're going to be cold, which actually is just so not right. It's unbelievable. But that is another thing. People think low flow temperatures, you just won't get your building up to temperature. Emitter wise, you need underfloor heating. Heat pump won't work with radiators. It won't work with an air handling unit. Or you need to pull up all your floors and put new pipework down everywhere, and you need to have brand new radiators which are going to take up the entire space of your lounge, and you won't even be able to get your sofa in there, so don't do it. That's another myth. UK temperatures here, it's too cold for a heat pump to work, whether it's ground source or air source, it's too cold. Too expensive to run. Yeah, okay, and also it's not really a myth, but it's another thing that people have said is, well, we'll wait for hydrogen, we'll wait for that to be developed, and then we'll all use that instead of natural gas, and we'll carry on as we are. So those are some of the myths. So just to combat each one of those in turn, and of course there's a lot more myths than that, but those are the typical ones that come up time and again. So first of all, it's a new technology, it's not ready. As I've already said, heat pumps have been around for a very long time. The thermodynamic process has obviously always been there, but it was discovered and put to use in the 1800s. In the UK, there are thousands of heat pumps deployed, some of them great, some of them not so good. But unfortunately in the UK, because of the consistent low gas price that we've had up until very recently, that's actually held back people doing anything other than putting gas in. If you look at somewhere like Scandinavia, it's the opposite way around. They had high gas prices, so they had to go down either the biomass or the electric route. So they've been using heat pumps for a long time. In the UK, it's the same technology, it's the same box, but it's the fact that people are so used to having gas boilers, and now we're having to peel people off gas and actually put a heat pump in instead. So people think it's new, it's not. You need a well insulated house. It's always a good idea to reduce the heat demand of your house before you do anything. I mean, if you were having gas, if you had gas in your house, well insulated house is going to reduce your gas bill. So it's always a good idea. Fabric first is always the first thing that we would look at on the job. But if you look at some of the National Trust properties, some of the big stately homes in the UK, fabric first is just not an option. You can't put double glazing in some of those properties. You can't externally clad them. You might be able to put some loft insulation, possibly, but they're still having heat pumps put in, and they're still working extremely well. So it's not a blocker. You just have to design it correctly. Which brings me to the next point. So low flow temperatures won't heat a building. As I say, if you need 21 degrees in your lounge, do you need to generate 80 degrees seawater at your boiler? The answer is no. As long as you've designed the system correctly and taken into account the building as a whole, which may mean upgrading some emitters, or it may not. It's not a given. So provided that you have designed the system correctly, it's not a problem. And then the other question is, what's the low flow temperature? So traditionally heat pumps have worked at say 45, 50 degrees flow. Now we have the natural refrigerant heat pumps coming on board, which can operate at 70 degrees, 80 degrees, 90 degrees with ammonia. Obviously, going back to the original aim of efficiency, the lower the flow temperature, the better, because you will get better efficiencies. But you can actually deliver 80 to 90 degrees C into big heat networks and into buildings. So, you know, heat pumps don't necessarily just produce 40 degrees C, and therefore you have to have masses of underfloor heating. It's not the case anymore. Again, underfloor heating, providing that you've sized your radiators or your other emitters correctly. You might find that your radiators are actually oversized. So if that's the case, the chances are you might be okay with a heat pump. But again, it comes down to the design. Has it been considered what the emitters are, and are they correctly sized for the temperatures? The UK is not too cold for a heat pump. If it works okay in Scandinavia, which is slightly colder than the UK, as long as those temperatures are warmer than the refrigerant, you're going to get boiling of the refrigerant. So therefore, you're going to get heat transfer. That's it, basically. You've just got to make sure, again, I'm going to keep saying it, as long as it's been designed correctly, you've taken account of what the temperature is outside, whether that's ground temperature or air temperature, the heat pump will be absolutely fine. Too expensive. They are in the UK more expensive than a gas boiler. There's no getting away from that. However, things like the boiler upgrade scheme do help with the capital cost. But really, you need to be looking at this as a whole life thing, as an ongoing cost saving. So how are you going to run your heat pump efficiently so that your electricity bill doesn't go off the scale? How are you going to make use of on-site generation if you've got solar PV? How are you going to make use of, say, battery storage or thermal storage? All those things can be wrapped together to make a very well-performing, low-cost system. And it isn't just a case of, right, let's just put a heat pump in and, oh, hey presto, it has cost us a lot more money. Well, actually, again, has it been designed properly? Have you understood the costs before you've started? And finally, the thing about hydrogen. Yes, hydrogen has a place, but when will it be ready? I don't know. How much is it going to cost? And how green, how is it going to be grey hydrogen, blue hydrogen, green hydrogen? It's not clear yet what that is going to be.